Alright, good day friends. Welcome you once again to another class with eLearning Global. So thank you for subscribing for our subscribers, and those of you that are yet to subscribe, please do well to subscribe and also like this video and comment on the comment section. So today we'll be talking on calculus, problems from calculus. I got some questions from students from enough calculus questions that they want me to solve, so we'll be dealing on them. Maybe in subsequent classes we will talk on calculus, we teach on calculus limits, and so those questions you can't understand, we deal on everything. So problems on mathematics, they are free meats. Alright, so we're going to deal with them even at this time. So our first question here is evaluate limit as x tends to -1 for x cube minus 3 over x square plus 1. Alright, so now how do we solve this? Simply impute x, wherever you see x, put -1. Alright, and then you solve the equation. So with this is simply going to be -1 cube minus 3 over -1 square plus 1, right? So this is simply -1 raised to power 3 is -1 minus 3 all over -1 square is +1, that is 1 plus 1, giving us -4 over 2, which is going to be -2. All right, so next question is the same limit question. Evaluate x raised to power 3 minus 2x square plus 2x plus 6. Alright, so here limit as x still tends to -1. So the same thing we're going to do here. Put -1 everywhere you see x, -1 cube minus 2 bracket -1 square plus 2 brackets -1. And please be careful with your sign. Be careful with your sign, because that's where the lecturer wants to test your ability, whether you know the sign, how to do your sign and not make mistake. Alright, so this is -1 cube, which is still -1. This is -2 times -1 squares. Board mass, solve us in the bracket first. -1 square is +1, right? Times -2, making it -2. If it does go straight up here now and multiply, you're going to get plus, but it's minus. Alright, -1 square is +1 times -2, make here -2. Then this is +2 times -1, this is -2 again, plus 6. So this -2 minus 1, that is -5 plus 6, which should give us 1. Alright, let's move further. Another question comes: determine the point of discontinuity of this function. Determine the point of discontinuity of the function f of x is equal to 5 over x plus 3. So now this is a very easy question. If you don't understand the definition of function, you may not be able to answer this. So now, what is the definition of function? Function tells us that function is a rule that assigns certain number as inputs and assigns to each of them a definite output. What is that telling us is that when you put a value inside, you must get a definite value outside. So that value is within the range of 0 to as much as you want. Alright, so 0 is a value, 1 is a value, 2 is a value, 3 is a value. But the point whereby this function is continuous is when it no longer a function. And because a function, for the value you put a value into it, it must give you a value. That is, for every input there is a definite output. That's the definition of a function. For every input there's a definite output. So discontinuity of the function is whereby when you put an input and you don't get an output. Are you getting it? And the only time you not get an output here is when here is 3. When here is -3. But if here is -3, we go to be -3 plus 3, making here 0. And we know that 5 over 0 is math error. If you type that in your calculator, it will tell you math error. There is no answer. So this is telling you that when you put -3 here, you are going to get 5 over 0. So that is math error. So it's at that point that the function is discontinuous, because a function, when you put an input, must give you an output, must give you an answer. Mind you, that answer can be 0. It can be 0, it can be 1, it can be negative, it can be positive, it can be 0, whatever value it is. But you must get an answer. Are we together? But when you are no longer getting an answer, that's when it's not discontinuous. So for a function to be said to be discontinuous is when the denominator of that function is equal to 0. Alright? So anything over 0 is discontinuous for a function. 100 over 0 is discontinuous. Are we together? So the only thing that will make here 5 over 0 is when you put minus 3. So that's simply 5 over minus 3 plus 3. That is 5 equals to 0. So at the point whereby x is minus 3, this function is discontinuous. Alright, another question before us now. Practically almost the same thing. If f of x is equals to 5x plus 1 over x squared plus 1, find f brackets minus 1. Alright, f of minus 1. So practically impute minus 1 into this function. Alright, so this is going to be 5 brackets minus 1 plus 1 over minus 1 square plus 1. Alright, so this is minus 5 plus 1 over what? 1 plus 1. So this is what? Minus 4 over 2, giving us minus 2. Okay, so there's another question here. Alright, so at what point is a function said to be continuous? At what point is a function said to be continuous? Alright, simple answer to this is a function is said to be continuous when it is continuous at every point of its domain. Yes, what is the domain? The domain is the independent variable. The independent variable. So what I simply explain it is much more explanation to that, but what I just explain to students is that since the domain is the independent variable and the range depends on the domain, so like when we say area of a circle equals to pi arrow square, right? This area is depending on the value of arrow, not arrow square, arrow. When you know arrow, that's when you can know arrow square. Pi here is a constant. So arrow here now is the independent variable or the domain, while a here is the dependent variable, alright, or the range, and this is a constant. Okay, so a is depending on the value of arrow. When we have a circle now, and the circle here, we know what arrow is 3, for example. So when we know what 3 is, 3 squared times 22 over 7 will now give us a. So a is depending on the value of arrow. If arrow changes to 4, a will change. All together, if arrow changes to 5, a will change. So a is depending on the value of arrow. That's why a is dependent variable. While arrow is not dependent on anything, it's being dependent on. So it's the independent variable range. So when this is continuous, as far as this one is continuous, as far as this one has a value, a definite value, as far as that is definite value, it means that function is correct. It's not discontinuous. You know what discontinuous mean? When the denominator is not 0 and it now leads you to math error, no answer. But once they see an answer, when that things, the values of the dependent variable or domain is continuous, then that function will definitely be continuous. Because it all depends on the domain with the independent variable. So that's why the answer is it is continuous at every point of its domain. Alright, so moving forward, we have a limit question here, which is actually going to be very nice. Evaluate the limit, the limit as x tends to 3 for this equation x squared minus 9 over x minus 3. Alright, now looking at this, if I impute 3 into this x directly, I'm going to get 9 over 9, 3 over 3. This is going to be 0, no issue with getting 0 up. But once you get 0 down, it's already discontinuous. Are you seeing it? It's already discontinuous. And And when we're not told, if you look at the options were 0, A 0, B 6, C 4, D -6. Alright, so we are not told in the option that is discontinuous. So this is already telling us now that there's supposed to be an answer. So as a mathematician, what do? You remember, look at the numerator. There's something that can be done to this numerator. What we were taught, I think in secondary school, we were taught something called difference of two squares, right? And this is actually a difference of two squares, because this is x is squared and this is 3 squared to give 9. So I can actually represent this as the difference of two squares. Maybe I'll teach that in another video. So as not to waste time, I'll just express this immediately. This is going to be x plus 3, x minus 3. Alright, and this is x minus 3 here. The same thing. So this will simply cancel this, giving us x plus 3. So at this point now, I'm safe to impute 3 here, because I'm not going to get a terrible answer. I'm not going to get something that's going to make it discontinuous. Alright, so this is now going to be 3 plus 3, making the answer 6, which is in the option. Okay, so just a quick tip here. Once you want to, before you always check before you impute a value for x inside an equation given, always check the denominator. If you impute that, will it give you a denominator of 0? If it does, then check the numerator. If there's something you can do, to make that function not to be discontinuous. Alright, so that's for that. Let's move forward. There's a question that came here also. It said represent the interval domain using a pair of brackets. Alright, represent. Alright, so looking at this question, if you have not been taught this, well, I hope I can explain it here before doing a whole video on this topic. So represent the interval domain using a pair of brackets for p squared less than or equal to 49. So we know the solution of this, a quick one, p squared less than or equal to 49. If I'm to take the square root of this is going to be what? P is less than or equal to what? 7, right? So this is the square root. P is less than or equal to what? 7. So this is going to be plus or minus. Why? Because the square root of a number can either be positive or negative. Square root of a number can either be positive or negative, because -7 times -7 will give me 49. 7 times 7 will give me 49. But then I don't want to put the plus or minus. If I come here and say the absolute value of P, now I can say it's 7. But without putting this absolute value, I must put the plus or minus here. So using this to represent it completely, I'll put here it's either -7, either x is greater than or equal to -7 or less than or equal to 7. So this is the range, plus or minus, right? So now once it's greater than or equal to, or you see greater than equal to or less than equal to, once it's an equal to sign under, we present it with closed brackets. -7, 7. Alright, -7, 7. But assuming here was this equal to sign was not here, it's going to be open brackets. It's going to be open brackets -7, 7. Right? So we get that. I'm going to do a teaching on this so we can get this accurately. Alright, so this is another question that was given to us. If y is equal to 3 over 1 over x cube, find dy dx. So simply representing this, you make, alright, so you say this equals to y, the same thing as 3 over x cube, right? Just use it to multiply it. This is simply 3 times 1 over x cube. Okay, x cube, sorry. So you just use to multiply the up. So now indices, we know that if we want to make this to become a whole number, we are going to add a negative here, right? This is 3x raised by minus 3. Alright, so now differentiating this, that is the y dx. Differentiate this. You know the general formula for the y dx is, alright, if y is equal to axn, the y dx is now nax n minus 1. So this simply means use here to multiply here, minus 1 from here. That's how to solve the y dx using the formula method. Now there's a first principle, but this one is in the formula method. Alright, so please follow me. This times this minus 1, that is out of this here. This times n times a is na, the n minus 1. So simply that's what I'm going to do here. So this is going to be minus 3 times 3. So the y over the x is now equal to be minus 3 times 3, that's minus 9, x minus 3 minus 1 minus 4 altogether. So this is the answer for this. So moving forward here, alright, another question, indicate the point of discontinuity of y is equal to 5x squared minus 1. Point of discontinuity. Alright, point of discontinuity. So this is going to be what did I say you're going to do about this? Look for the value that if you put in the denominator, is going to make the denominator what? 0. So the only thing you can put here to make here 0 is what? It's going to be 1 or minus 1, right? 1 or minus 1, because if you put 1 here, it's going to be 5 over 1 square is still 1, 1 minus 1, 0. If you put minus 1 square is still 1, 1 minus 1, 0. Except the options are not given, so you say it's going to be 1 or minus 1. But in a case where the options are given, let's say you have A is equal to minus 2, B is equal to 2, C is equal to minus 1, D is equal to 3. The answer is going to be what? C. Okay? They can't put these two in the same option because both of them will make it discontinuous. Alright, so this here is the answer. But assuming here was not negative, is still the answer. Alright. So let's move forward. Alright, another question for us here. Find the derivative. As you can see, I'm trying to be very fast for time. I'm going to do a teaching on this also, so during the teaching I can exhaust this. Alright, to find the derivative of sine x, right? The derivative of sine x is cos x. Just put it in your mind. The derivative of cos x is what? Minus sine x. Then the derivative of tan x is what? Sec square x. So now these are just easy things I'm giving just so you know. Okay, so that is that. Then moving forward, all right, another question for us here is if, all right, if y is equal to x plus sine x, find y prime. Y prime is the same as dy dx. All right, so y prime is also dy dx, is also f of x prime. All right, f of x prime, the same thing. So now find dy dx of this. Dy dx of x now is going to be 1 times 1 here, which is still 1. 1 minus 1 is 0. Anything raised by 0 is 1. So here it's going to be 1 dy over dx is equal to be 1 plus dy derivative of sine x is what? Cos x plus cos x. So this is the answer for this. Alright, then for when you tell you given y is equal to x sine x, find y prime. Now these two are different. This is normal differentiation method, but now this is the product of this and this. This cannot be solved normally. This is going to be solved using product rule. So now in product rule, there is a rule that is used to solve this. So I'll be explaining that, and we're going to end with this. Then in our class on calculus, we're going to be teaching on all of these rules: chain rule, product rule, quotient rule, exponential function, logarithm, differentiation, and all of that. So this is the last question we're going to be solving. Product rule. We're going to be using product rule to solve this question. So product rule simply tells us that if y is equal to uv, that is two variables are multiplying each other, two values, u is multiplying v, the y dx is u times d v over dx plus v times du over dx. All right, so this is simply carry u and multiply by the differentiation of v, then add it to carry v multiplied by the multiplied by the differentiation of u. That's what it's saying. Short form is u v prime plus v u prime, right? U times dy dv times dv dx plus v times du dx. All right, so how do you do this? Let's use that question that was given to us. Y is equal to x sine x. So I'm going to give these values the variable. Let's say this is u and sine x is v, right? So it means that all right, so from here now we know that u is now equals to x, v is now equals to sine x, right? This u, this is v. So we are trying to get this, that is the y over the x, which is this. So now if u is x, du dx, that is u prime, is now going to be what? 1. This time this minus this is going to give you 1. Then if v is sine x, the v dx is now going to be what? Sine x is what? Cos x. You can remember, this is going to be cos x, right? So that is for v prime. So imputing this back into here, u is what? Remember, u is x, so it's going to be x bracket v prime is what? Cos x. Then plus v is what? Sine x bracket what? U prime is what? 1. You can see if you cannot get them, just be substituting. You can see how easy it is. So this is simply x times cos x is x cos x plus sine x times 1 sine x. So this is the answer of this question. So thank you very much. We're going to be solving more on this later in our video. Also going to be solving the limits when it's limits as x tends to infinity. We are going to be solving on exponential equations, solving on logarithm differentiations. We're going to be solving on chain rule, more on product rule. We're going to be dealing on quotient rule and all of this. So hang around and watch our next video. So if you enjoyed the video, drop your questions on the comment section, and also share this video to your friends so that they can also understand all these questions and calculus in general. So please subscribe if you have not subscribed, and if you have, please turn on the notification button. Thank you very much, and God bless you.